Let us see the second question. Solve the Laplace equation for the following square mesh with the given boundary conditions. So here the boundary conditions are given like this for a square mesh ABCD. So now if you notice the boundary condition, here the boundary condition are symmetric about the diagonals AC as well as BD. Okay, so AC means here if you notice the boundary condition about this diagonal. So this is the diagonal AC. If you fold about this diagonal, what happened here is this 2 and this 2 get coincide. Similarly, this 3 and this 3. Again this 3 and this 3 and this 2 and this 2. Both are all are same values. Because of same value, we can say that this boundary values, that is this square mesh, is symmetric about the diagonal AC. Similarly, if we notice another diagonal along BD, next diagonal is BD. About the diagonal BD also, if you notice, we are having same values 3 3, 2 2, again 2 2, again 3 3. So here, so we can conclude that the given square mesh is symmetric about both the diagonals AC and BD. So this is symmetric about AC and BD. What about the solution here? We have to calculate what is U1, U2, intermediate point U3 and then U4, right? So our aim is to find out U1, U2, U3 and U4. But because of this symmetric property, what happened about the line AC, if you consider U2 and U3 also coincide with each other, so from this we can say U2 is equal to U3, right? U2 is equal to U3, and about the diagonal BD, if you notice, U1 and U4 get coincide, so U1 is equal to U4. So using symmetric property, we can come to the conclusion that U2 is equal to U3 and U1 is equal to U4. So instead of finding all the four values separately, it's enough to find out two values alone, that is U1 and U2 alone. So that here we can write down the formula for U1 and U2 using standard 5-point formula. Okay, so here we are not going to use iteration method. Directly by elimination method we can solve it. So what about the formula here? Using standard 5-point formula, right? By standard 5-point formula. So first let us write U1. U1 is what? U1 is equal to 1 by 4 into the values lies horizontally, that is 2 plus 2 plus U2 plus U3. Similarly, what about U2? U2 is 1 by 4 into U1 plus 3 plus 3 plus U4. Here we don't want to write for U3, U4 because U3 and U4 already equivalent to U1 and U2. So here we can note it that it is enough to find U1 and U2. So we have written the formula for U1 and U2 alone. So again here U2, we are having U2 and U3 in this formula. So U3 is also equivalent to U2. So this U3 can be replaced as U2. So still we can simplify this as 1 by 4 into 2 plus 2 is 4. And then this becomes 2U2. Similarly, what about this problem? This formula is 1 by 4 into 6 plus, that is 3 plus 3, 6. Now U1 and U4 are both same. So we can write it as 2U1. Okay. So now we are having two equations, 1 and 2. Both the equations are equations in terms of two variables U1 and U2. So now everyone know how to solve these two equations using elimination method. So using elimination method, we can try to solve this. Now equation 1 can be written like this. Similarly, equation 2 we can write like this. Now these two equations are two equations with two unknowns U1 and U2. Now solving the both the equations, you will obtain u1 equal to 2.33 and u2 is equal to 2.67. That is, this by usual elimination method we can solve. Either you can multiply the first equation by 2, so you'll be getting here 4u2, again already here 4u2, subtract it. So u2 get cancelled, then you can calculate u1. Once you know u1, we can put it in any one of the equation to find u2. So finally you'll be getting this answer. So already in the first problem we solved a Laplace equation by using iteration method, and second problem without iteration method we saw how to solve it by usual elimination method. Okay, so in the previous problem, the first problem, what we did is there is no symmetric property based on the boundary conditions because all are different boundary values, so that we can't able to use symmetric property. So we found out all the four values separately. Now here we have symmetric property. Using that we have reduced four values into two values. So because of two unknowns, it is easy to use elimination method rather than the iteration method. So it is your wish. For this problem also, if you want to use iteration method also, you can use. Similarly, in the first problem for four variables also, if you want to use elimination method also, we can find out. So anyway, you can find either you can use iteration method or elimination method, but final answer will be getting the same.
So now let us see the following question. Solve the equation, that is Laplace equation, for the following square mesh with the given boundary conditions using Liebmann's iteration process. So here square mesh has been given with the with the boundary conditions or boundary values given. So based on this boundary value, you have to start the iteration and then we have to find out the value of u. So if you notice here, apart from the boundary values, the intermediate values are 9 values here: u1, u2, u3, u4, u5, u6, u7, u8, u9. So totally 9 values you have to find out. Right. So that here, if we see the boundary values, if the boundary values are same, if we can able to apply the symmetric property, we can apply, so that instead of finding 9 values we can simplify that. But here if you see the boundary values, we can't able to use symmetric property, but because all the boundary values are different, so that we have to find all the 9 values separately using iteration method. We have to notice the following steps to do the calculation. Step number 1 is first iteration. Before starting the first iteration, here we have to use SFPF. SFPF means standard 5-point formula for U5 in the first iteration. Next, after finding U5, then we have to find U1, U3, U7, U9 using diagonal 5-point formula. And then after that, we have to find out U2, U4, U6, U8 using standard 5-point formula. That is, this is what we have to use in the first iteration. For the first iteration, we have to start from U5. We should not start from U1. So we have to start from U5 because U5 is the center value out of all the 9. So once you find out U5, then using U5 we can use diagonal 5-point formula to calculate the remaining values U1, U3, U7, U9, and then we can find U2, U4, U6, U8 again using standard 5-point formula. So now if you see this diagram, so the center value is U5. So under step number 1, in the first iteration, first we have to calculate this U5, which is the mid value. Okay. So how to you calculate U5 using standard 5-point formula? So standard 5-point formula means we have to take the adjacent values horizontally and vertically, but the adjacent values are still unknown, so that we can move to the next step. That is, here we can move to the boundary, so that u0 plus 17 plus 21 plus 12.1 divided by 4. That will give you the first value of u5. Right. So that is equal to 12.5. Next, coming to u1. Now if you notice second step under first iteration, U1, U3, U7 and U9 can be calculated using DFPF, that is diagonal 5-point formula, because these are placed diagonally to this U5. Because if you notice U1, all the diagonal elements are known. So using that, that is 0 plus 0 plus 17.0 plus 12.5. If you calculate, you can find out U1, that is 7.4. Next, similarly, you can calculate U3, that is 17.3. This is 12.5, 17 plus 18.6 plus 21 divided by 4 will give you 17.3. Similarly, U7. So U7 means 0 plus 0 plus 12.5 plus 12.1 divided by 4. It will give you 6.2. Next is U9. Similarly, U9 also you can use diagonal 5-point formula. It will give you 13.7. So likewise, second we can find out U1, U3, U7, U9 using diagonal 5-point formula. Again, what are the values left out is U2, U4, U6, U8. So all these can be calculated using standard 5-point formula. Because U2, if you apply standard 5-point formula, U1 7.4, next 17 is the boundary value, U3 equal to 17.3 and U5 is equal to 12.5. So all the values are known. So using this we can calculate U2 by standard 5-point formula. Similarly, U4 gives you 6.5, U6 is 16.1 and U8 is 11.1. So likewise, these are the values, 9 values under first iteration. So this only in the first iteration alone you have to use U5 by standard 5-point, U1, U3, U7, U9 by standard 5-point and the remaining value U2, U4, U6, U8 by standard 5-point again. Okay, so this is the first step and the first iteration. Now, if you see the second step, after completing first iteration, we are moving to the second iteration. For second iteration onwards, we have to use only standard 5-point formula for all the 9 values because all the remaining values are unknown to you. So that starting from U1, U2, U3 can come in order itself. So U1, U2, U3, everything you can calculate using only standard 5-point formula. So once you complete the second iteration, again you move to the third iteration, fourth iteration likewise. You have to repeat the process until all the 9 values of U should be same in the consecutive iterations. Once you have the consecutive iterations, all the U values are same, there you can stop and you can conclude that is to be the solution. Right. So now we can move on to the calculation. Now after the first iteration, now for the second iteration we have to use only standard 5-point formula starting from U1. So start from U1 here. U1 you can use standard 5-point formula, that is 0 plus 11.1 plus 6.5 plus 13.6 divided by 4 will give you 7.8. Let me write the values over here itself. Next, U2 also use a standard 5-point formula, that is here while considering U1 we have to take the latest value, that is you have to remember the Gauss Seidel method. So we have to use the latest value. So instead of taking 7.4 you have to take 7.8 for U1, then plus 17 plus 17.3 plus 12.5 divided by 4 will give you 13.7. Next, similarly for U3 it is 17.9, U4 it is 6.6, next is 11.9, 16.1, 6.6, 11.1 and then 14.3. So while using standard 5-point formula, you have to take the latest value. So these are the values of second iteration. Similarly, you can do the calculation, you will be getting the third iteration. Now, if you see the values of third iteration and fourth iteration, you are getting all the 9 values are same. So we can stop the iteration, and finally we can conclude the answer is 7.9 for U1, 13.7 for U2, 17.9 for U3 and all the remaining values. So this method is called as iteration method or iteration process, Liebmann's iteration process. And then here I have shown you the values in the table itself, that is in the mesh itself. Instead of that, you can form a table separately for all the 9 values. You can form a table with the 9 columns and you can write the values one by one. Because here, since we are having the answer at the fourth iteration, it is possible to write here within this given box itself. If you have more number of iterations, it is impossible to write it over here. So in such case, you can form a table and then you can write the values depending upon the iterations.